Hello guys, Assalamualaikum warahmatullahi wabarakatuh and a very good afternoon. So here we have Dr. Amirul Aizat. We would like to interview about battery because all of you curious about battery. So exactly you can get the paper of Dr. Amirul, Facet Synthesis of Microwave on the Science Direct. You can download from the Science Direct. So basically this video we want to interview Dr. Amirul about the common electrochemical analysis that we need to publish at least one lithium-ion battery. Okay, before that, can we start a little bit introduction about the list of analyzation that we need to do when we are doing lithium-ion battery?
Okay, so basically, I would say that the analysis is quite similar with supercapacitor. Okay, where we need to run for cyclic voltammetry, and then we have electrochemical impedance spectroscopy, which is known as EIS, and then we have also charge discharge, which is the main among all those two. Okay, and then yeah, I think that's all. Only these three, but we can, from this analysis, we can expand more. Okay, to get more results. Yeah.
Okay, thank you for the clarification. So let's look at your paper, the analyzation number 1.
Okay.
So as you can see, you can download the paper. So number 1, we are talking about the GCD curve of charge discharge. But normally in supercapacitor, the graph is not like this. The graph is commonly maybe the triangle, either distorted or we can see a plateau. However, in battery is slightly different. They are plotting voltage versus specific capacity. Can you explain regard on that?
Okay, so basically, like I said, the GCD analysis is it is quite similar with supercapacitor, where we need to put the applied current, we need to set the voltage range, okay, and then how many cycles that you want to run. Okay, so basically from that paper you can see that actually I didn't put, you cannot see the triangular shape because first is the graph is different. Okay, for the triangular shape is actually the graph is voltage versus time. Okay, for that graph actually you see that the charge and discharge curve is overlapping. Okay, because of the graph is actually voltage versus specific capacity. Okay.
Okay, thank you. So how about during supercapacitor we are study with different current density?
Okay.
How about the first graph? Is it important or compulsory to study different current density or just fixed one?
Okay. For us, normally we run at different current density only for the optimized sample. Okay. But for if you have like 2-3 samples, normally we will fix at one current density, and then we will set at the same cycle, and then we'll see the comparison for the performance.
Okay, good. How about the shape? Because we learned that when we are dealing with battery type material, we should have a plateau shape.
Okay.
Is it important for you to discover that?
Alright, so yes, should be, it is very necessary to see the plateau, because this plateau actually reflect the cyclic voltammetry graph. Okay, for example, I think later on we will go for the cyclic voltammetry graph. Let's say you see that there's a reduction peak at certain voltage. Normally this voltage will be also present in the plateau in the GCD. Okay, so that we can see that it is complement, both graph actually complement to each other.
Okay,
yeah.
Understand.
And then plateau actually is representing the lithiation and dilithiation of the lithium ion into your material or go out from your material. Yeah.
Okay, good. So the GCD should in agreement with your CV analysis.
Correct. Yeah.
Okay, move on to the second characterization, which is the retention study. So when I'm looking at your paper, you are study your sample for 80 cycle, comparing to the supercapacitor is very limited. Can you explain why?
Okay, you mean the cycle, is it?
Yeah,
okay.
Should be maybe 1,000, 5,000.
Okay. So we can, if you can run more than 1,000 cycles, I think it will be much better. It will be much convincing. But due to our incapability of the machine, because our current is quite low, our current that we apply is very low. That's why we are not capable to run too much cycles, because we have ongoing samples need to run. Yeah.
Okay, one more additional question. Is it common for people to report less than 100 cycle for lithium-ion battery?
Okay. First, you need to understand between half cell and full cell. Normally, for full cell, yes, we will run like for more than 100 cycles, like even 1,000 cycles. But for half cell, I think it is it is enough to provide only like 80 cycles, just to see the capability of the materials, whether it is actually suitable to be used for full cell. Yeah.
Okay, good. Okay, then from that graph or that analysis, we can derive into the Coulombic efficiency also.
Correct.
Can you explain a little bit how to get the Coulombic efficiency?
Okay. Alright. First, Coulombic efficiency defined as the capacity of the charge capacity and also the discharge capacity. Okay, so let's say if you got 100% Coulombic efficiency, meaning that the value of charge capacity is equivalent with the value of discharge capacity. Okay, so the formula for half cell battery, okay, for the Coulombic efficiency is actually charge capacity divided by discharge capacity times with 100%. Okay, and for full cell is vice versa. Right.
Okay, so the value close to 100 is good, right?
Yes. Good.
Okay, it's almost the same with the supercapacitor, but in supercapacitor we're measuring at device where discharge divided by charge.
Correct.
Okay, next for impedance is normal. Everyone know about the impedance spectroscopy. So it should have Wabak also?
Not necessary.
Not necessary.
Because in battery we actually focusing more on the semicircle. Semicircle, okay, so we know that semicircles represent the charge transfer resistance.
Yeah.
Okay, and then it is good if you can run the resistance before and after charge discharge.
Okay, to see the capability
Yes.
of the material.
Okay. Yeah.
And maybe two last question,
Okay.
last analyzation about the, I think the retention study at different current density.
Alright.
If you all can see the graph number E. So this analysis, because normally in supercapacitor we are dealing with GCD curve at different current density, but I'm looking at your graph. You have cycle number and also capacity. It's almost like retention or stability study,
Correct.
but different current density.
Okay. Alright.
So I want to know about the purpose of this.
Okay, so previously, like I said, we just run only one current density, okay, and then we calculate the cycling stability. But however, to see the capability of your material, the optimized samples, you need to run at different current density. So if you see from the graph, we actually run from low current density to higher current density, and then we go back to the original current density to see whether the value of the capacity is actually same as the initial capacity. So if let's say you got almost the same, which means that your materials, your material is actually very good and can retain at more cycles.
So basically, theoretically, the value should follow the trend. Like when you increase the current density, the value of specific capacity will
Decrease.
be decreased.
Correct. Yes.
Is it the same explanation? Not the electrolyte ion doesn't have enough time.
Yes,
to
the same
explore.
thing. Because it's actually referring to the current applied. So current applied meaning that if you increase the current, so the process will be much faster. So that's why the capacity will be decreased. Yeah.
Okay. Last but not least, you put a cyclic voltammetry graph.
Okay.
So normally we are study CV at first. You
Okay.
put at last.
Okay.
Any justification on that?
Okay. For battery, there's no format. Okay, you can run at the first place, or you can run at the end. But like I said, for battery performance, to see the performance of the battery, just GCD is the main analysis comparing with the CV, because we are measuring the capacity from the GCD. Okay, but for CV actually we run the cyclic voltammetry is actually only to see the mechanism for the lithiation and dilithiation. Okay, so as you can see that some papers actually you can see like very visible and obvious peak, redox peak. Okay, that's actually showing that the lithiation and dilithiation occur in the material. Yeah.
So basically, when we see from the graph, the anodic and cathodic peaks. Is it important to read the anodic peak or cathodic peak?
Alright. In the first cycles, okay, normally we will see in the reduction peak. Okay, the reduction peak actually represent that the lithium ion actually extract out from the lithium metal.
So delithiation.
Yes, delithiation. And don't forget that actually when the reduction peak is not just referring to the lithium metal side. Actually, it's a simultaneous reaction. So meaning that once the lithium metal has oxidized the lithium ion, so the lithium ion will be transferred into our material. Yeah.
Okay, so the reduction peak is very important.
I would say that the oxidation peak is also important, but in the first cycles, the reduction peak is the main indicator.
So you need to see a little bit curve on that.
Yes. So I recommend to run CV, do not use higher scan rate, because normally higher scan rate you cannot see very clear the redox peak.
Yes, from your graph I see you are using 0.1 millivolt, very slow scan rate.
Yes. Even you see the graph is the peak is not really visible, so I recommend to use lower scan rate. Yeah.
Okay, even for your GCD also low current density, right?
Correct. Very low.
So we cannot use higher than 1?
You can run, but normally you cannot measure the capacity because the process is very fast. So normally the capacity is like almost to zero.
Okay, thank you, Dr. Amirul Aizat. So actually, if you follow what he explaining, you can actually publish at least one paper like this with complete electrochemical characterization. So any last word for Dr. Amirul for those who are interested to study lithium-ion battery?
Okay, alright. So if you see from this paper, I just published only until for half cell analysis. So my recommendation, if let's say you have a good performance, I mean the material that you prepared, you got very high performance. So I recommend you can provide also the full cell result, so that this paper can go for higher impact journal.
Okay, thank you very much. Thank you for watching. That's all for today. Thank you. Bye.